Okay, last video. So we are on units 4 and 5. Tell me each of the Earth's 4 spheres. Give me 2 examples of things that belong to the sphere. Biosphere, that's all living things. So I am part of the biosphere. My roommates, animals, cats, and dogs are part of the biosphere. Hydrosphere is all of the water on Earth. So that could be lakes, oceans, rivers, whatever, clouds even. Lithosphere/geosphere, that is all of the Earth material, rock, soil, whatever. So I said metals and sand. Those are also part of the lithosphere. Atmosphere, anything that is part of the gases that surround the Earth. So that could be oxygen, carbon dioxide, methane, I don't know. There's a lot of different things you can do. Nitrogen, helium. Give the name of each part of the water cycle and give a short definition. So here's our water cycle. A over here is evaporation. That is liquid water heating up and becoming a gas. We have B, which is condensation. It is condensing into clouds. C, precipitation, is the water falling back to the Earth's surface. So that could be as any form of precipitation. So that could be rain, snow, hail, whatever. Infiltration is when the water comes back down to the surface and it goes actually into the Earth, like absorbs into the ground, into the lithosphere. Or we can see surface runoff, E, which is the water flowing off of the Earth's surface and back into the rivers, lakes, oceans, whatever. Today in Juneau, Alaska, it is sunny and slightly warm. It's supposed to say warm. Oops. I'm like opening a bunch of crap. Bro, I don't want to draw boxes. The frick? Help. How do I shut this shit off? Get off my screen, bruh. I don't want to draw anything. Exit drawing. Thank you. Jeez. Sorry about that. It is sunny and slightly warm at 60 degrees. What is the climate of Juneau, Alaska? So generally, Alaska, it's cold and dry. That's the climate of Alaska. It's cold and dry. Climate is long-term patterns. Weather is short-term. So I'm trying to throw you off by saying that it's warm and sunny. The weather is warm and sunny that particular day, but generally it is cold and dry. That is the climate. That's the long-term patterns. Label each part of the carbon cycle. Here are the words given to you. I put them in right here so you can see where they're at. Obviously, CO2 in the atmosphere is going to be CO2 in the atmosphere, in the air. Photosynthesis, that is the only arrow that is going into the plant. Remember, the only way that carbon can get out of the atmosphere is when it is going into plants who use it for photosynthesis. Any living thing that lives and breathes and has processes gives off CO2 as it breathes through cellular respiration as part of the mitochondria, like part of that reaction that's giving you energy to do things. CO2 is a byproduct of that reaction. So all living things cellularly respirate. When things die, they die and decompose. When decomposed things are left in the lithosphere for long enough, they become fossil fuels. We dig up those fossil fuels and we burn them. That's called combustion, and that brings more CO2 back into the atmosphere. If humans cut down too many trees, how would that affect the carbon cycle? How would those effects to the carbon cycle affect all of Earth's 4 spheres? Write at least 5 sentences total. So I didn't feel like typing for this. But we're going to include CO2 in the atmosphere, greenhouse gases, and climate change. So let's see. So we're cutting down too many trees. That means the trees can't absorb the CO2 back out of the atmosphere. So there should be some CO2 in the atmosphere, but not too much. Plants help us take out a certain amount of it so that we have a safe amount. But if we cut down too many trees, we're not going to have those trees photosynthesizing and taking that CO2 out of the atmosphere. So what we see is this buildup of greenhouse gases. CO2 is a greenhouse gas. There are other ones as well, but CO2 is a big contributor. So we'll see way too many greenhouse gases in our atmosphere. That's going to trap in too much heat, and we are going to see a climate change effect that is going to change the climate to make it generally warmer the more CO2 is in the atmosphere, that is kind of working as a blanket that is heating up the Earth and trapping that heat in. How would that affect all 4 spheres? So if it gets way too hot on the planet, we saw with like the polar bear example, right? It melted the ice caps. That ended up affecting the polar bear's life because it cannot live when it has no ice to live on. So the polar bears die. That's affecting the biosphere. So hydrosphere, it melts ice into water, affecting the hydrosphere. Kills polar bears, affecting the biosphere. Obviously the atmosphere was affected because there's more CO2 in the atmosphere than there should be. And then what are we leaving off? Oh yeah, lithosphere. I mean, a couple different ways that climate change could affect the lithosphere. Causes droughts in places like here in Arizona, right? So our lithosphere is getting drier than it should be. We don't have enough moisture in the soil. That's one of many things. We see stronger storms in other areas of the planet that can cause erosion to the lithosphere, etc. Okay, so now moving on to the food web. I didn't draw a food web because I can't draw with my mouse, so I just picked one off the internet. You guys have to make your own, though. But yeah, I know this doesn't follow the rules. There's not one producer. There's more, okay? Whatever. Imagine there was a drought that killed many producers. What would happen to the rest of the food web? So, producers die. That means that these primary consumers don't have enough to eat. They die. These guys, not enough of them exist. These guys don't have enough food. They die. These guys don't exist. They don't have enough food. They die as well. Basically, everyone ends up dying off. If we hunt off the tertiary consumer, an apex predator, one of these guys, what would happen to the rest of the food web? Well, whatever these guys eat, there's going to be more of, because they're not being hunted. So when there's more of the secondary consumers, they're going to be eating more of the primary consumers. So secondary consumers are going to go up because they're not getting eaten, but then they're going to eat too many primary consumers. So the primary consumers are going to go down. When there's not a lot of primary consumers eating plants, the producer population will go up. So it's kind of a really weird chain reaction, like kind of flip-flop, flip-flop. Let's see. Thinking back to the bunny simulation that we did last week, when we changed the environment from regular to snowy, what happened to the rabbit's fur? Why did this happen? Use the words natural selection, trait, and adaptation in your answer. So, the bunnies. We gave them a gene that could turn their fur, white. And what we saw is when we gave them this mutation and we changed the environment to the snowy environment, it was whiter because it was covered in snow. So we saw that the bunnies started naturally selecting for the white fur because the brown ones were getting hunted off by the wolves. They were not living very long at all because they were getting hunted off before they could reproduce. Meanwhile, all of the rabbits that had white fur were able to survive and breed more because they weren't getting hunted off, and we saw that the rabbits kind of gradually turned white instead of brown. So that trait of having white fur was kind of naturally selected for over the course of several generations, and it was an adaptation to survive that new white and snowy environment. It helped them adapt, and it helped so that the predators would not be able to detect them. They were kind of camouflaged in the snow. Alright, that about wraps this up. If you guys are actually watching this, I hope that your finals go really well. And if you're watching this from my class, I guarantee you're going to do pretty darn well on my final. So good luck on that. Try not to worry too much. And thank you guys so much. It has been a really awesome year. Despite everything, the COVID and everything, I couldn't have asked for like a better first year teaching. You guys are super cool. So thank you very much.